All right. You want to know why this works. Okay, so what we're really looking at here is the average rate of change. If we're going to recall the formula, whether you know it or not, we're going to recall the formula, average velocity on the interval from A to B, as the function of B minus the function of A over B minus A. It's the change in Y over the change in X. It's slope. So let's think of B as equaling A plus some quantity H. So we have the interval A to A plus H. So we take the average velocity of the interval A to plus H and we write F of A plus H minus F of A over A plus H minus A. That becomes F of A plus H minus F of A over H. This is something we call the difference quotient. You may or may not have seen it in pre-calc. Okay? So what we're going for here, because H is going to be 0, we're looking for 0 change in the points. We're looking for the tangent line there. We end up going with a screen that is not moving. Come on. A limit of, as H approaches 0, of F of A plus H minus F of A over H. And that becomes what we call the definition of a derivative. So let's talk about x squared. We want to find the tangent line on x squared, okay, from A to A plus H. So we go the limit, as H approaches 0, of of A plus H squared minus A squared all over H. So I have to do out the algebra here. So this becomes A plus H times A plus H minus A squared all over H. Now, you're going to do this so much that you're going to memorize this. That A plus H squared is equal to A squared plus 2AH plus H squared. Okay? So, the limit of H approaches 0 of A squared plus 2AH plus H squared minus A squared all over H. A squareds go away, leaving me with the limit as H approaches 0 of 2AH plus H squared all over H. I'm going to factor out the H. And we get 2A plus H all over H. H's go away. The limit of H approaches 0 of 2A plus H just equals 2A. And we are done. So the slope of the tangent line at any point A is 2 times A. I feel like I might have blown your minds a little bit, but stay tuned. We're going to learn more about this. So get comfortable with this. Okay?